In our first example, we have the square root of 18. So if we were to compare the numbers that I underlined, none of them matches with 18. So that is not a perfect square. So in the event you don't have a perfect square number, what you're going to do is you're actually going to split it into two numbers. So again, you're going to split it into two numbers where one of them is a factor. So a factor meaning two numbers that multiply. So let me point out that you're going to split it into two numbers, a times b, inside the radical, inside the square root. So you must find a number for a, and you must find a number for b that will multiply into 18. So, starting off with my lowest, 4 does not go into 18, but 9 does. So I can rewrite the square root of 18 as the square root of 9 times 2. So I can rewrite that. Now the reason is, now you're able to pull a number that's a perfect square. So if you can, and you did pull a number that's a perfect square, in this case the 9, so now I'm going to split the square root into 2. So in the event where you're able to split into two numbers where one of them is a perfect square numbers like the ones I underlined, so I'm going to rewrite it as the square root of 9 times the square root of 2. Now once you do that, then the only one that you can simplify, that you can actually do the square root, is this one right here. So it will be the square root of 9 will be 3 times, you cannot simplify the square root. If you do with a calculator, it will be converted into a decimal. So I'm just going to leave it like this. Now, after you simplify everything that you can, in this case, in this example, the only one I was able to simplify was the square root of 9. Next, I'm just going to multiply. So 3 times the square root of 2 will simply be 3 square root of 2. Just like that. And that is my final answer. So square root of 18 will simplify into 3 square root of 2. Now, this part, I would not recommend that you stop here. I would actually recommend that you stop here. If you stop here, then you're going to have points taken off. But so make sure you simplify it into this form. So to review, with this example, we split into two numbers where one of them is a perfect square number. In the second example, we have the square root of 27. So it's not a perfect square. Now even though it's close to 25, 5 does not go into 27. So we're going to start off breaking into two numbers. 4 does not go into 27, but 9 does. So I'm going to use 9 as a factor. So I'm going to write 9 here. 9 times 3 will equal to 27, so that means I'm going to have the square root over the 9 and the 3. Once I break it down to two numbers, where one of them is a perfect square number, I can split it into two square roots. So I repeat, I'm going to split into two square root. The square root of 9 times the square root of 3. Now, the only ones I can simplify is the square root of 9, so this one right here. So the square root of 9 will be 3, and then I bring down the other one. I cannot simplify the square root of 3. That will be converted to a decimal if you type that in to the calculator. So we're going to leave it as radical. We're not going to have it change into decimal. Leave it in radicals. Now, 3 times square root of 3 will be 3 square root of 3. And that's my final answer. So it's very similar to the last one because we use 9 as a factor. But the one thing we have to watch out for is when we have a number that has multiple ways of simplifying, meaning more than one number to use. What I mean is, in the first example and the second example, the only perfect square number we could use is 9. Now, there's going to be some cases where you might be able to use 4 or 16 at the same time, or 36 and maybe 9 at the same time, 4 and 36 at the same time. So the only best way is use the highest number, and you will see in the next example. Alright, in this example we have the square root of 32. Now, first you're going to break it down into two numbers. So starting with the 4. 4 does go into 32, so it's going to be 4 times 8 into 32. Now, since they're multiplying, you can actually split it into two square roots. So I'm going to write square root of 4 times square root of 8. Now I'm going to simplify my square root of 4, which will become 2. So it's going to be 2 times square root of 8. Now, here's the problem. We can actually keep going, simplifying, because the square root of 8 can actually still be broken down into two numbers. So, the two numbers that you can use for 8 is 4 and 2. So, I'm going to write my 2, the one I simplified already. I'm going to simplify the square root of 8 and it becomes 4 times 2. Just like that. So again, I broke down the 8 into 4 times 2, where 4 is a perfect square number. So I'm going to split it into two square root. So this is going to be 2 times square root of 4 times square root of 2, just like that. Now the only one that I can simplify is this square root of 4. So it's going to become 2 times square root of 4 is 2. You cannot simplify square root of 2 without converting to a decimal, so it will stay the same, just like that. Alright. From there, if there's nothing else you can simplify, if there's nothing else you can break down, then I'm going to multiply. So 2 times 2, those are my whole numbers. That's outside the radical. So 2 times 2 is 4. This I cannot simplify, so it will stay as square root of 4. So that will be our final answer for the square root of 32. Now, this is one way. Next, we're going to do another way that will be shorter. And I'm going to write it right here. The square root of 32. Now, instead of 4, we check on other higher numbers, higher perfect square numbers you could use. 9 does not go into 32, but 16 does. 16 can go into 32, so I'm going to break 32 into two numbers, where one of them is 16. So I'm going to write 16 here. So it will be 16 times 2. When you multiply those two numbers, it will become 32. So I broke down 32 into two factors, 16 and 2. Now I'm going to break it into two square roots, so the square root of 16 times the square root of 2, like that. Now the only one I can simplify is the square root of 16. The square root of 16 is 4. I cannot simplify the square root of 2, so it will stay the same. So 4 times square root of 2 is simply 4 square root of 2. Just like that. So that's my final answer. So you see how they both equal to the same number? The first one that we did was multiple steps. So 1, 2, 3, 4, 5, 6. Over here, 1, 2, 3. So I actually did half of the work. So that's what I mean by be very careful Now this one I would call the famous 32, or the famous square root of 32, is because most of the time this is what everybody would use. 4 and 8. And if you do that, you have to check if you can break down the other factors into smaller numbers. Just like how I did here. And we end up doing 6 steps. Now, once you practice, you will gauge and you will have a better grasp on which number you could use. So for 32, or the famous square root of 32, is besides 4, is there any higher perfect square numbers you could use as a factor? In this case, 16 was a factor for 32 and it's higher, so you can use 16. If you can use a higher perfect square number, then that means you should use it, and it will save you a lot of work. It will save you a lot of time. If not, what I have seen in the past is students, they start off correctly, but sometimes they think they have to keep going, and when they keep going, so this is 6 steps. I have seen students that wrote like 10 steps or 15 steps, and they went too far when they should have stopped right here. So be very careful when identifying what perfect square numbers you can use. We're going to do one more example similar to this. So in this example, we have the square root of 72. So checking what numbers you could use. So we see that the first one, 4, it could go into 72, but that's going to be a lot of work. So I'm going to skip 4. 9 can go into 72. So let's try 9. So instead of 4, we're going to do 9, because 9 is higher than 4. 9 times 8. So 9 times 8 will equal to 72. Since I broke down and one of them is a perfect square number, I'm going to write as 2 separate square roots. So the square root of 9 times the square root of 8. The square root of 9 will become 3. I bring down the square root of 8. Now, this part right here is very similar, or the exact same as the last example. I can still break this down. So I'm going to break 8 into 4 times 2. And then just like before, I'm going to break it into 2 square roots. So the square root of 4 and the square root of 2. Just like that. Now, the only one I can simplify is the square root of 4. So the 3 stay the same. The square root of 4 will become 2. And this will also stay the same, square root of 2. So I'm going to multiply my whole numbers. That's outside the radical. So 3 times 2 is 6. And then square root of 2. So I ended up doing 1, 2, 3, 4, 5, 6 steps to get my final answer. So 6 square root of 2. Now the reason I didn't do 4 is because you would do more steps. But again, 4 does go into square root of 72. Now let's check if we can use a perfect square number that's higher than 9. 16 won't go into 72, so we can't use 16. 25 won't go into 72, so we're not going to use 25. But 36 can go into 72, so we're going to use 36. Meaning, we're going to simplify the square root of 72 right here. So to break down 72 using 36, it would be 36 times 2, like this. And then I'm going to break it down into square root of 36 times square root of 2. And then you can actually simplify this square root of 36 because it's a perfect square number. That's going to become 6. Now, when you do that, 6 times square root of 2 will be 6 square root of 2. Just like that. And that's my final answer. And again, notice how this answer is exactly the same as the previous answer. So in the previous part, 1, 2, 3, 4, 5, 6 steps. Here, I used a higher perfect square number that was able to go into 72, and I did it in 1, 2, 3 steps. Now, you could use 4, but you're going to do more than 6 steps. So 4, if you use 4 as a factor, more than 6 steps. If you use 9, you do it in 6 steps. If you use 36, you do it in 3 steps. Now, I didn't use the other numbers because 49 does not go into 72, 64 does not go into 72, 81 is higher than 72, so I ignore any numbers that's higher than 72. So, when you're simplifying radicals, you gotta make sure, are you using the correct perfect square number? So in this case, instead of 4, instead of 9, the one you can use is 36 because 36 can go into 72 and it's higher than 9 and 4. If you choose to use a lower perfect square number, you're going to end up doing more steps just like the first part. But if you use a higher number that can actually go into, for example, 72, you will end up doing less steps. But that's going to come from you actually checking and making sure it's correct.